Okay, we're continuing with the Blue Ridge hot tubs problem on page 21. This is earlier we worked through the problem and we set it up. We did not set it up yet. We understood the problem and identified the different constraints and the objective function. So here are the 5 steps in formulating linear programming models. First, understand the problem. That's what we did in the last section. Second, identify the decision variables, and we did that when we were understanding the problem too. We identified the decision variables as how much of product 1 to make and how much of product 2 to make, the 2 hot tubs. We want to formulate this mathematically, so we're going to call it X1 is the number of aqua spas to produce, X2 is the number of hydroluxes to produce. The third step is state the objective function as a linear combination of the decision variables. Well, the decision variables are how many of aqua spas to make and how many hydroluxes to make. So the objective function is going to be in terms of X1 and X2. And we also identified that this was a maximized profit. So since we're maximizing profit, the objective function coefficients are going to be profit. And if you recall, it was $350 profit for one and $300 profit for the other. So we are maximizing profit. We don't need to put profit, but we're maximizing. That just goes to say 350 times X1 plus 300 times X2. So we want to maximize profit, and we get $350 for every X1 we make and $300 for every X2 we make. That's objective function. Step 4, state the constraints as linear combinations of the decision variables. The decision variables are X1 and X2, so they will be in terms of X1s and X2s. Let's see, the first constraint is pumps. 1 pump to make aqua spa and 1 pump to make the hydrolux. So 1 times however many we make of X1 plus 1 times however many we make of X2. So it's basically X1 plus X2 has to be less than or equal to 200 because that's our constraint. We only have 200 pumps, so we can't make 201 of these things. Labor. It takes 9 hours to make product X1 and it takes 6 hours to make X2. We're limited by 1,566 labor hours, so 9x1 plus 6x2 has to be less than or equal to 1,566. And then our third constraint is tubing. It takes 12 feet of tubing. And notice that these can be in terms of dollars, hours, feet. It doesn't matter, but each constraint, each row of constraint, it all needs to be in the same terms. But the constraints themselves can be completely different. 12 feet is used to make each of the first product, X1, and 16 feet for X2. So 12 times however many we make of X1 plus 16 times however many we make of X2 had better be less than or equal to our big old roll of 2,880 feet of tubing. Can't be more. We're limited. Finally, we want to identify any upper or lower bounds on the decision variables, and we decided, hey, we can make 0, but we can't make less than 0. So X1, which is the number of X1 we make, has to be at least 0. It can be more than 0, but it can't be less than 0. Same with X2. It can be 0, but it can't be less than 0. So those are lower bounds. Okay, so here it is mathematically. This is our linear programming model for Blue Ridge hot tubs. When you get the homework assignments and it asks you to write out the linear programming model, this is what it's looking for. At the very top, we put our objective function. We always put max or min. We've got to identify that. And then the objective function is 350 x1 plus 300 x2. The objective coefficients are 350 and 300. In terms of the constraints, and we have the first one is the pumps constraint, the second one is the hours, right? Hours constraint. The third one is the tubing constraint, and then we have our lower bounds. So this is it. It's formulated mathematically just the way we want it.